virtual. In this nugget, we're going to take a look at some of the common network components, things like network interface cards, protocol stacks, and so forth, and servers, clients, routers, and switches, and ask the very important question, which of these devices could we virtualize? Meaning, instead of having maybe a switch run on physical hardware, is it possible to make a switch in software and make a router in software and a PC in software and a server in software? And the answer is yes. Now, why would we want to do something like that? Well, if that's a good question for you, this is the nugget for you. We're going to take a look at how we'd virtualize items, things like routers, switches, and servers. Take a look at why, and I'll even show you a couple examples of some really current tools to do virtualization in the 21st century. Let's jump in. So let's start this conversation of virtualization by picking on somebody. We'll pick on this PC right here. Let's say that you and I want to go out and build from scratch a PC. So we get a shopping list, and on the shopping list we'd have to have some things like, for example, a processor, a CPU. Great, that's a good start. And we need some memory. And maybe a hard drive, some disk storage so that we could put our stuff somewhere. And what else would we need? A network interface card so we could participate on the network, and a video card, and probably a monitor, and a power supply, and a few other things as well. So we go out and we put all those together and we assemble the computer. We're real happy about it. And we also put an operating system on the hard drive so that when it first powers on, the operating system loads up. And let's take a moment and discuss what happens once the operating system boots up. A couple of things that happen. Number one, the operating system is going to look at the resources. What do I mean by resources? Well, it's going to say, okay, I've got this much memory and I've got this much disk storage. I mean, does your operating system know how much disk storage it has? It sure does. Does it know what kind of video card it has? Does it know what kind of network card it has? Does it know what kind of CPU? The answer is yes. So it's going to look at all the resources. And then once it knows about those resources, it can go ahead and use them. Well, what if we did this? What if we made a pretend environment? And I'll do this in a different color. And this is an environment that we have a list of CPU, of memory, hard drive, just identifiers, not really the real resources, but just a list of the elements, the video, the network interface card. And when the operating system boots up, instead of actually looking at what it thinks it's looking at as hardware and resources, it looks at this list. So we could just create a list and have an operating system look at the list and say, oh, great, I've got this CPU and this memory and this hard drive and this video and this network interface card and this video card. And, we could fool it. And that's what virtualization is doing. We're taking an operating system like Windows or Linux or you name it, and we can put it inside this sandbox and we can point it to a list of resources and it can boot up, think those resources are real. And here's the deal. When the operating system, it makes calls, it says, I'd like to use this resource. In our virtual environment, we can just lie and say, yep, you're doing it. Oh, great job. So basically, we're creating this entire bubble of lies around the operating system. So it thinks it's on this type of hardware. It thinks it has this type of video card. And all of it's just emulated. So when I talk about virtualization in general, and our focus here is to take a look at virtual network components, I want to point out that anything, virtually anything, virtually means almost, virtually anything can be virtualized. So how is virtualization possible? The answer is we take systems that are expecting certain resources to be available, and in software, we make it look like they're available. Now, why would we ever do that? I mean, what's the whole purpose of doing the virtualization game? And it's a good question. Back in the 90s, when the internet was fairly new, if somebody wanted to have a server, a web server, they would buy a server, they would load an operating system on it, and then they would make it available on the internet by giving it a public address, a public IP address, and making it reachable. And what if they wanted a second server? Well, they put a second server up and a third server and a fourth server. And pretty soon you have these data centers. A data center is a fancy way of saying a location that has lots of resources for computing. And so here we have 8 different servers. They're all plugged into the network. So we have a network cable here. And actually, you know and I know that this would be a switch. They're all plugged into the switch, and they're all chewing up electricity like crazy. And you know what the average utilization might be on some of these? Maybe this guy's at 5%. This guy's at 15%. Is at maybe 40%. But you know, somewhere between 5 and 10% is not a bad number of how it used to be. So let's go ahead and say that's the usage. So now in the data center, we've got 8 servers. Hopefully we're generating revenue out of them. And they're not all busy. And each one has a power supply. Each one has a case. Each one has memory. And as a result, it's very, very expensive. It's not only expensive to purchase, which is a capital expense, but it's also expensive to run them. That's an operational expense. So CapEx and OpEx talk about the EX is expenditures, and capital is cash, money up front, and op is for operations, for keeping them going. So it didn't make a lot. I mean, it's really expensive, but hey, you needed to have them. Well, now what we can do, because each one of them are not really running at 100%, instead of creating separate boxes, we can do this. We could purchase a big server, and you see how I'm drawing it physically big to give the impression of a big server. And on this one server, we can go ahead and maybe put a bunch of memory in it. Maybe an average server has 8 gigs of RAM or 16 gigabytes of RAM. So instead of doing that, we could maybe do 128 gigabytes of RAM. That's memory that the computer can go ahead and work with, which could be, you know, quite a bit depending on who you talk to. So then we could go ahead and give it some storage. I'll draw this as a hard drive. And maybe we give it a hard drive of 100 terabytes, which is also quite a bit. And this hard drive doesn't have to be directly attached. It can also be network attached. So we could have it available on the network. So maybe this server could use that hard drive space, and other servers could as well. So if it's attached on the network, we could call it network attached storage. That's one of the many acronyms of NAS, of what it means. Network access, NAS also could refer to network access server, but in this case it's network attached storage. So anyway, we take this 128 gigabyte system, and it's just hardware. And then inside of it, we can actually run something called a hypervisor. Now, a hypervisor is a really thin layer of control. HYPERVISOR, because every computer has to have some type of operating system. One of the most popular hypervisors that runs on a very big machine like this is something made by VMware. VMWARE. And VMware makes something called ESX, which is absolutely amazing. They're not the only people, but they're one of them. So you run this hypervisor software on this big box, and now what does it do? Nothing. The hypervisor knows about the network interface cards. It knows there's lots of memory available and some storage, but it's not useful for anyone yet until we add some guests. And when we add a guest, we're actually adding a virtual machine. So before we had 8 servers. Now we can add, for example, server 1 here, server 2 here, server 3 here. I'm just doing an apples for apples comparison. And 5, 6, 7, and 8. And of those 8 servers, guess what we're doing? As far as power goes, we only have the power for one box. And the power for one large box is a lot less than the power for 8 separate boxes. Also, we're leveraging the storage. We're not wasting disk space, every single server having to have its own dedicated disk space. And we're also sharing the memory. So as long as there's enough RAM for each one of these devices to do its job, it's great. One of the really cool things about virtualization is that we maybe could have 2 boxes. So this is box 1. Box 2, and we could actually move logically the servers from one box to another in the event that things got busy. Maybe things get really busy and this one server says, I need more resources, and this box is physically out of resources. We could logically move this server over to a totally different physical box where there's more resources available and answer the call. For example, let's say somebody they have a server that's supporting something that they're selling. And it's Super Bowl, and there's this big rush for people going online and buying something. Well, when that rush happens, the system could sense that there's an incredible rush or demand at the moment. It could say, wow, this server's getting hammered. Let's move this server to a physically separate box. It'll be totally transparent to the users, except they'll get a better response time as they hit that one server, that one logical server. Then when it dies down, it could be moved back to this box. We could power off this machine. It all could be automated so we could save energy. So if you don't need the physical hardware running, it can go ahead and turn off. So that's kind of a glimpse into the world of networking as far as virtualization. But I wanted to, with that glimpse, I wanted to give you a few key elements. How is it possible? Well, we discussed that. It's possible because we can lie. We can lie to operating systems to make them think that they're running on their own dedicated box, when in reality they're sharing space with others, but they don't know it. Another thing too is, take a look at our topology here. Here we have a switch, we have a PC, we have a router connected to another router who has another switch connected and devices there who's connected out to the internet. Now, could we virtualize this? Could we virtualize our whole network? And the answer is yes. Yes, we could. Now, let's talk about what the functionality here is first before we virtualize it. Why are these devices on a different network than these devices? And the reason for that is security. A lot of it's security. We want to keep them separate so we can have different security controls as traffic enters this network compared to this network. So having things separate makes a lot easier for security purposes. So we just put everybody in one little network. It wouldn't be as secure, and there might be too much capacity to handle it all. So we divide up the network for the purpose of security. So if we were going to do this all virtually, it might look something like this. On a server, like the big server with 128 gigabytes of memory, we create a virtual machine. It's called a VM. And that virtual machine could represent this guy right here. So how does the end user actually use it? That's a good question. If this virtual machine is running on this computer inside in the big server in the data center, the end user, so here's Bob, he's happy. You know why he's happy? Because he gets to run a computer. So what he would do is he would be on his little laptop or computer right here. And as he worked on the computer, it would really be a remote control session to this computer here. Now, as far as remote control is concerned, one of the protocols we talked about was RDP, Remote Desktop Protocol. So if the virtual machine is running right here, what's the benefit of that? Well, the benefit of that is we can control it in the network, meaning we're in charge of the policy and everything else. And this client, what could he use to access it? He could use, let's list it, he could use an iPad. He could use a really old computer. He could use a new computer. He could use a Mac. He could use Windows. Because whatever he's running right here on this computer right here, it doesn't even matter. Because he's just doing a remote control session of the machine, the virtual machine that's running inside this bigger environment. So for control purposes, that's how we could work that out. Now, let's talk about this server here. I'll use a different color. So these servers, our email server and web server, they're right here. Good enough. And do we want this machine, we'll call it PC1, we want him to be able to talk to the email, I'll just call it server 1 and server A and server B. Do we want him to talk to server A and server B? The answer is yes. So how would we do that? We network. Now, the concepts that we learned in the earlier nuggets, this is why it's so fun, they apply. They're always going to apply. The basic concepts apply about the OSI reference model and how the TCP/IP protocol stack works. So what we could do is this. If we had a whole bunch of virtual machines, having a virtual printer wouldn't really make sense. But let's say these are all virtual machines. So that guy is right there. We could have a virtual switch, and then we could have a virtual router. And that virtual router could be connected to another virtual router, or the same one if we had enough ports. And that virtual router could be connected to a virtual switch, and that could be connected to those servers. Are you with me on this? I mean, we're working with this physical topology down here, but at the end of the day, if we wanted to virtualize all this, we could. Now, why would anybody do that? Well, let's think about it. We have the users who are accessing the network, and they may be wireless even. So you might have a wireless client, no switches involved, just an access point, which is a fancy way of saying a wire. A whole bunch of virtual machines. Having a virtual printer wouldn't really make sense, but let's say these are all virtual machines. So that guy is right there. We could have a virtual switch, and then we could have a virtual router. And that virtual router could be connected to another virtual router, or the same one if we had enough ports. And that virtual router could be connected to a virtual switch, and that could be connected to those servers. Are you with me on this? I mean, we're working with this physical topology down here, but at the end of the day, if we wanted to virtualize all this, we could. Now, why would anybody do that? Well, let's think about it. We have the users who are accessing the network, and they may be wireless even. So you might have a wireless client, no switches involved, just an access point, which is a fancy way of saying a wireless device that's letting them communicate. So you don't have to buy physical switches, you don't have to buy physical routers, you don't have to buy physical servers, you don't have to buy that switch, you don't have to buy that router, and basically you've got all of this logically inside of a big box, a big server. So why would we do that? It's a lot less expensive to do that, and there's a lot better control on this too. I mean, for the cost of several switches, you could actually get one server and virtualize most of it. So that's a lot, and I'm super happy we've been through a few nuggets before we talked about this, but I want to reinforce a couple concepts. If this computer right here, let me get a different color. If this computer right here wanted to communicate with this server, what would the process be? Well, Keith, it would probably start by a user typing in. Let's say he wants to go to the web server, this one right here. So he wants to go to a web server. What's the user going to do? Well, the user sitting at this computer, which is really remote controlling this computer, the user would type in www.server.com. You with me? So that's what the user does. What's the next thing that happens? Well, the next thing that happens is this computer is going to say, I need to know what? What does he need to know based on the name? What does this computer need to know to make an IP packet go? The answer is the computer needs the IP address of that server. So what do? So we do a DNS request. In order for that DNS request to go out to a DNS server, we're going to need the layer 2 address of our router. So there's going to be ARP involved first. We have ARP, then DNS. Then once we have the IP address, we're going to make an HTTP request to that server. And the entire process is exactly the same. So just because it's happening inside of a box doesn't mean the process is any different. So by having logical layer 2 switches and our virtual layer 2 switches and virtual routers, virtual servers, and virtual PCs, we can do it all in a box. So let's take a look at the process here. Virtualization is possible because we're lying to devices. We're making it appear. And why would we do that? There's cost savings, there's control and security elements that are benefits from that. What can be virtualized? Can we virtualize a server? Yes, we can. Can we virtualize a desktop or a client, aka almost the same thing, a device making a request? Yes, we can. Can we virtualize a router, a switch, or a firewall? And the answer is yes. Now, what exactly is a firewall? A firewall is usually a layer 3 device making forwarding decisions based on IP addresses, but it has an attitude. And the attitude is, for example, at the corporate headquarters, if I wanted to put a firewall right here, the firewall would say, nothing gets in the network. Nothing comes in from the internet into our network, period. And that's what a firewall's job is, to stop traffic. And then we can make exceptions for that. We can say, Mr. Firewall, it's okay. You can allow, for example, we want customers to come to our web server, so we can poke holes in the firewall and say, traffic can come into our web server if it's going to port 80, well-known port for web services. Traffic can come in if it's destined to this IP address and if it's destined to the well-known port of 25, which would be our SMTP traffic. But other than that, everything is denied. At the same time, this firewall is going to keep track of this user as this user goes out to the internet. Why? Because if this user went out to the internet, he's expecting a reply back. So our firewall can act as something called a stateful firewall. It's remembering that this PC went out to the internet so that it can dynamically allow the return traffic back from the internet to that PC. So everything that's initiating from the outside world, if it's a new conversation, is denied. Virtually everything is denied by default, but reply traffic is allowed. So that's what firewalls do. It's one really important aspect of a firewall. But can it be virtualized? Yes, it can. Okay, what about this guy right here, a phone system? Now, we talked about how we could put telephones on our networks and have a telephone actually send its messages via packets, IP packets, from one side to another. And then on the other side, where there's a telephone, it would go ahead and the user could listen. And we talked about a couple of protocols: Session Initiation Protocol, SIP, for setting up the call, and Real-Time Transport Protocol, RTP, for the UDP of sending the traffic back and forth. Well, in getting that call set up between these two devices, phone 1 and phone 2, in the past, in a traditional phone system, we had something called a PBX. That's a private branch exchange. And that was the big computer, if you will, that when somebody dialed a phone and you pick up the handset, you dial a phone number, and it connects to their side, inside of a company, it was the PBX that was making it possible. Now, in the world today, there's a ton of systems that put phone calls together, which is a way beyond the scope of our course here. But in a small company, they could have a private branch exchange just to connect calls within their company. Well, can that be digitized? Yes. And so with IP phones, there's several products on the market today, but you can just think of a virtual PBX as just software running on that same huge server with other services as well, that when this guy picks up the phone, the call manager or whatever product you're purchasing, which is like a virtual PBX, is taking the logic and saying, okay, you're dialing this number. I need to make sure that it's identify where that other phone is. It makes sure the other phone rings, and once the two parties pick up, it says go, and then RTP allows packets to go back and forth. So it can be virtualized. So I'd like to open the kimono a little bit and share with you something now that we've had this discussion about what goes on in my world. I teach a lot of really cool stuff, and I teach a lot of really cool people like you. And when I'm creating this content, I'm doing it with you in mind, as if I'm sitting right beside you. We're at a couple computers, and we're going through this together. And I appreciate your attention. I do. It means a lot to me that you're with me. So let me share with you something, and let me see if you recognize it. And let me just scroll in a little bit here. You kind of recognize this topology a little bit? Does it look familiar? Maybe to this? This is a virtualized environment. Most of my demonstrations I do, because of convenience, I do in a virtualized space. What this is router 1 right here. It's got a switch hanging off of it, and I've got a cloud. Off of that cloud, I hang off a virtual PC. So the PC we've been using, which is this guy right here the entire time, it's just, I mean, it really is Windows. It really is Windows XP, but it's running in a virtualized environment. Off of R2, I've got a switch. I don't have the two servers in place, but I could certainly add a couple. There's R3. It's our remote branch office in Reno, Nevada. Here's the ISP service provider. And what I'm actually doing, too, is I'm connecting this fake router to the real internet. So the reason this PC can get to the real internet is because it actually goes through the path. Does ARP happen between the PC and this router? Yep. Does a DNS request go from this PC out to the DNS server? Yep. Does the HTTP request go all the way out through the internet to the real resources? The answer is yes. So what I've done is I've married the virtualized environment, and I've meshed it up against the public real network, the internet, and it's seamless. And that's just a demonstration. So normally this wouldn't be my first thing I'd tell everybody, but I'm sharing it with you because I want you to see the impact of where we're going. In data centers today, virtualization is a huge topic. So not only are we virtualizing the physical resources, we're also virtualizing the hardware that ESX runs on. So it's like a layer within a layer within a layer. One last thing I'd like to share with you, which I think you might find very interesting, is ESX. ESX is a fabulous, let me scroll this down so we can all see. ESX is a product from VMware that allows us to create these crazy virtualized environments. And they've got some management tools. And there's an awesome, oh my goodness, it's so good. There's a really good CBT Nuggets series on VMware. And I encourage, if you have any interest in that, to take that Nugget series as well. But this is a way to organize the resources. So these represent some physical servers. And inside, for example, inside this one physical server, I've got lots of other virtual machines. So these virtual machines, they don't know. They honestly don't know that they're living inside this one physical box. They think they've got their own dedicated hardware. They think they've got their own dedicated interfaces. So if we went, for example, to one of these, and there we go. Wow, it's taking a little time. So I'm going to right click and go to settings. And if we look at settings of one of these devices, check it out. That device thinks it has 3 gigs of memory. It thinks it has a couple CPUs, video card. It doesn't have anything. It's just a virtual machine that's running inside of ESX, which is making that virtualization that is lying to this machine. If we take a look at networking, it thinks it has a couple of network adapters. And if we wanted to network device, look at this. Here's the layer 2 address it thinks it has for that network card. And here's a different layer 2 address that it thinks it has for that network card. And there's the hard drive, the CD-ROM drive, everything. It's all there. So that's just a quick peek at some of the tools that are currently being used out there for in the world of virtualization. So one last thing I'd like to share with you, and I'm tempted just to go on and on and on and on about about the world of virtualization. But let me do this. Let me keep on task here. Our last piece is X as a service. Now, what does that mean? What does that mean, X as a service? Well, X could represent anything. So in the world of computer networks, let's say that you and I want to go into business and we need a web server. In the old days, a decade ago, we would say, okay, we need to buy a server, and then we need to purchase an IP address or lease an IP address from a service provider. We need to get that IP address inside of DNS, and we need to make sure we get the software on the web server running. And, we need a way to have users interface with that web server so they can make orders and place and do financial transactions. That's a headache. I mean, I just get tired just thinking about it. So X as a service, we could actually purchase network as a service. And what does that mean, network as a service? And this acronym is NAAS. Well, we could just go to a service provider. Guess what they do for a living? Internet service provider provides internet access. But a different type of service provider could say, you know what? I've got switches and routers and servers running your web server software already. All you need to do is give us some money, and we'll do all the work for you. Now, what these are all rolling into, too, is we have network as a service. There's actually something called compute, which is computing power as a service. We also have infrastructure as a service. We have software as a service. For example, let's say you have 100 people and they all need word processing of some type. Well, you could go out and purchase all the word processing licenses if you wanted to, or you could have that as a service. So you could actually, there's lots of not gray areas, but there's lots of possibilities for purchasing what you need and using the services that somebody else already has in place. What it really boils down to, which is, I don't know if it's super obvious, it all boils down to this: the cloud. And that's when people talk about the cloud, that's what they're talking about. And let's talk about a couple applications. I'll talk to you about a couple that I use that I love personally. One is I use Dropbox. I just love Dropbox. And that's a cloud service. So when we take a look at networking as a service, what would Dropbox be? Well, that would be storage as a service. I don't have to manage that storage. All I have to do is pay for it. I click a button on my computer, it synchronizes the folders that I want to, and it's done. So when people talk about cloud computing, I'll tell you why this is so exciting too. It's not magic. Guess what the people up in the cloud have to do? They have to set up all the services, the networking, the security to still make it happen. So cloud is fantastic, but we're still doing the same amount of work. It's just different people. So down here in this company, when I had an IT department that had to manage all this gear and all these servers and all these servers and these clients, I had to manage them all. Maybe I could outsource that to a service provider and say, you know what? I need computing, I need web servers, I need email servers, I need security in these fashions, and then it just gets transferred up to the cloud. So we might connect with our network, with our laptops, iPads, what have you, take remote control of the device that we're supposed to work with in the cloud as a user and use it. And all the switching, routing, servers, services, and everything else are all managed by the cloud. But here's the deal. Inside the cloud, they're still doing the work. And that's where that's where the corporate jobs are moving to. So when we make sure our skills are solid, and as we apply our skills to the physical networks, those same skills are going to apply to the cloud, and then we're going to have to warm up to the idea of doing things virtualized. For example, everything that we already know how to do down here, we're simply going to transfer those skills and do them inside the cloud. So nothing is wasted, zero waste, but now you have an inside sneak peek, if you will, at where things are going here in the 21st century. So just a quick overview, make sure I covered all my points with you. How is virtualization possible? We simply make an environment in software that emulates the hardware that used to be there. So for a router, when the operating system boots up, it thinks, you know what? This is the hardware, everything's good. It doesn't know any better. Switches, same thing, and there's special virtualized versions of routers and switches that we can use in the virtualized space as well. For PCs and servers, Windows, Linux, Macs, Apples, it's very, very easy to do that, lots of software. Everything can be virtualized, and why would we ever want to do it? We'd want to do it for cost savings, control savings, and if everything's virtualized, it can all be set up for network as a service. So you just purchase that service, and then you don't have to manage all the details down here on your own. You can simply pay a provider to do it all for you and not have to worry about all the overhead and the hardware that typically is involved. Well, that about wraps it up. Again, just a side note, I would strongly encourage you, if you've got a subscription to CBT Nuggets, I would encourage you, if you have interest in the virtualization, go check out the CBT Nuggets on VMware. And he covers ESX. He does a fantastic job on it, and I think you'd enjoy it. So for our session here, I hope this information has been informative for you, and I'd like to thank you for viewing.